Hey guys, today we're going to learn how to find the particular solution of an initial value problem as we're continuing our conversation about differential equations. If you are not comfortable either verifying or finding the general solution of a differential equation, feel free to check out my other videos going step by step through how to tackle those problems. The links will be in the description. So let's dive right into this first example here. We have some differential equation as outlined here, and we've already defined our solution, our general solution. And we know that this is a general solution because there is some constant of integration here. Now, in addition to those two things, we are given that when we evaluate our solution at x equals 0, we get 2. So we're supposed to use this information in order to solve for c and get the particular solution of this differential equation. So the first step is to plug in this 0 for x in our solution. So anywhere where we have an x, so here in the exponential function, we will plug in 0. So that's what we did here. So we plugged in 0 for x, and now we can set that equal to 2 because that is what we are told we are evaluating the solution at. Now we can solve for c by looking at what we get when we look for our function at x equals 0. So if we look at the exponential portion, we know that any function to the power of 0 equals 1. So that's how we get this 1 here. And if we just bring over the c and bring down the 2, through simple algebra, we can solve for c equals 2. Finally, we take this and we plug it back into our original solution, our general solution, and we find that our particular solution for this initial value problem is y of x equals 2, or our c value that we found, times e to the negative 2.5x squared, where the e to negative 2.5x squared we have gotten from our original general solution here. So let's try another example. Here, using similar concepts, we have some differential equation, and we already have the solution for this differential equation as defined by y of x here. We are given some initial value saying that if we evaluate our general solution where x equals pi over 2, it will equal 0. Again, we are looking for this constant of integration here, and this will result in a particular solution for this initial value problem. Again, first step is to plug in pi over 2 wherever there's an x in our general solution. So that's what we're doing here. This pi over 2 is going right into our general solution, and we're setting that equal to 0 because we're getting that from our initial value. And now we're going to evaluate so we can find our constant of integration c. So if we evaluate this, we can see that if we have sine squared of pi over 2, that is equal to 1. So that's how we get this 1 here. We bring over our constant of integration, so it's c times 1, and we also bring over our 4. So we have c plus 4 equals 0. Through simple algebra, we can see that c equals negative 4. Now all we have to do is plug this into our general solution, and now we have our particular solution. So here we can see that c has made its way into our general solution here, and we copied our general solution here. And keep in mind, this -4 is not being distributed all the way through the solution. It is only in this first part as it is shown in the general solution. So we can say the particular solution for this initial value problem is the instance when y of x equals -4 sine squared of x plus 4.